The network controller, NIC network interface controller, connects the computer to the local area network, LAN. Network cards have an ISA or PCI interface. Most of them can also be equipped with boot EEPROM, which include a minimal basic network operating system, so that the computer can be connected to the network without a hard drive or disk drive. There are three major groups of networks in terms of size: local area network, LAN, metropolitan area network, MAN, and world area network, WAN. A LAN consists of a central machine, server, various server machines, such as a print server, and workstations. Each machine, more specifically a network card, has an address that is either physically entered or assigned by the central machine within the specified range. MAN is a common network of several LANs, e.g. intranet. WAN is a long-distance network that connects many LANs and MANs, e.g. the internet. The standard for interconnecting networks is set by OSI, Open Systems Interconnection. It defines 7 layers that each network must provide, usually layers 3 to 5 are merged. First physical layer, second data link layer, third network layer, fourth transport layer, fifth session layer, sixth presentation layer, seventh application layer. The layers are superimposed on each other. For example, in order for the data link layer to be realized, the physical layer must be provided. There are 2 types of interface cards that determine what physical network you can connect to. The card with a BNC connector is connected to the local network via the coaxial cable, and the card with a TP, twisted pair, is connected to the local network via a twisted pair cable. There are 2 types of coaxial cable: thin, about 6 mm, thinner 10 BASE2, and thick, about 15 mm, thicker 10 BASE5 cable. Inside the coaxial cables is a copper wire surrounded by an insulating layer. For this, a shield, stocking, braided from cylindrical uninsulated wires, is pulled to prevent external interference signals and noises. The resistance of the cables ranges from 30 to 300 ohms. In the most common LAN technology, Ethernet LANs use 50 ohm cables. In an Ethernet network, a thin cable can connect up to 30 machines per cable segment, and a cable segment can connect up to 185 meters. A thick cable can connect up to 100 machines to a cable segment, and a cable segment can be up to 500 meters long. If the wire is lost, all computers in the segment will lose communication. A network can consist of several segments. The segments must be connected with an amplifier repeater device. The rupture does not spread through the repeater. The communication speed with a coaxial cable can be up to 10 megabits per second with a thin cable and up to 100 megabits per second with a thick cable. The card is connected to the coaxial cable via a T-splitter with a BNC connector. A twisted pair cable usually has 4 pairs of wires. The standard twisted pair cable is called UTP, unshielded twisted pair, and the shielded twisted cable is called STP, shielded twisted pair. With this cable system, integrated communication can also be realized, i.e. a telephone or video signal can be transmitted, for example. The cable can be up to 100 meters long from the network card to the hub or switch. Its data transfer rate is 10, 100 megabits per second or 1 gigabits per second, depending on the network cards and other network devices used. More recently, Ethernet technology has also been used on twisted pair cabling systems. With a 10 BASET twisted pair cable, the maximum length of a segment is 100 meters, with a 100 BASET cable 1000 meters. The structure of a network is determined by its protocol, the set of rules that record the type of communication and the form and control of the devices and systems that exchange data. Novell NetWare network systems use IPX/SPX, Internetwork Packet Exchange Sequenced Packet Exchange, Windows 95/98 SME, and Windows NT 2000, and newer OS networks use NetBEUI, NetBIOS, and TCP/IP, Transmission Control Protocol Internet Protocol. The structure is even determined by the topology of the network, that is, the system in which computers are connected to each other. The most common arrangement of networks communicating on coaxial cables is the bus topology, which connects the computers next to each other so that the signal travels to the selected machine from one machine to the next. It's relatively easy to build, but if it breaks in one place, the whole network stops. The 2 ends of the rail must be closed with a terminating resistor with the same resistance as the cable. UTP networks are arranged in a tree topology, that is, computers are arranged in a tree-like manner starting from the server machine. The soul of the topology is an active mains distribution and amplification device with interface resistors. A mains distribution device without a signal amplifier is called a passive distribution. The server and workstation cables are plugged into this device. The single input and multi-output network hub switch receives the incoming data and sends it attached to the card with the specified address. The network hub switches can be connected under network hub switches, as network hub switches share data transmission. There can be up to 3 network hub switches under each other. This is how the tree-like structure is built. In fact, the tree topology is the interconnection of several active network hub switch-centered star topologies. It is also possible to connect to a tree topology network with a coaxial cable, of course with network distributors with BNC connectors. A switch is very similar to an active network hub. It is also a distribution and amplification network element, but it does not distribute but addresses signals and switches data packets much faster than a network distributor. There is also a traditional star as well as a ring topology. In the traditional star topology, a wire goes from each workstation to the central machine. Its advantage is that, if a wire is interrupted, only the communication of the given machine is stopped. The disadvantage is that the server is often overloaded because when one machine sends a message to another, the data is sent to the server and the server forwards it to the receiving machine. In a ring topology network, each computer, including the server, is in direct contact with 2 neighboring computers. The first machine is connected to the second and last machines, thus creating an annular structure. Communication is structured by the sending computer passing the message to the person next to it, checking to see if it is for him, if so, processing it, if not, forwarding it to the person next to him, and so on. Multiple networks with the same protocol are connected to a network bridge or router. The main difference between a network bridge and a router is that a network bridge connects networks with different protocols, while networks with the same protocol as a router. A network bridge or router can be a computer with 2 separate network cards and a special filter program, but it can also be a separate device. Its job is to check if the message is addressed to a computer on the network or to a computer on another network. We can connect networks with different protocols, different physical media, using different procedures, but this requires a routing machine and gateway with special programs. Each network card has its own identifier. The MAC, Media Access Control, that allows it to be identified on the network. In a TCP/IP network, network devices have an IP address assigned to their MAC address. Networks can be connected not only with normal network cables but also with other communication channels, e.g. fiber optic cables with radio waves, such as Wi-Fi, wireless fidelity, etc. Network topologies. Left is the bus topology. Top is the star topology. Bottom, center and top is the tree topology. Right is the ring topology. Connecting networks with different protocols and topologies. There is a gateway between the 2 different protocol networks.